Follow up on today's episode. This is a second part of the question how to organize for optimal decision making, for optimal leaderless decision making, how to surface creative explanatory knowledge at the best possible levels, at the organic levels of organizations. This is a problem that we have in computer science, how to organize networks so they make decisions fast and keep following the mission or the value of the system. And this is a follow-up on that. I want to talk in particular about the question of iteration as the key fundamental concept of decentralized decision making. This is Not Even Wrong podcast. It's February 7, 2021. This is Krim Delko. Today is Sunday. There's no update today. So I spoke in the first part of today's episode, about generally the concept of theoretical wealth generation, or how should we think about the actual theory of what are the processes that lead to the generation of wealth. And we have a lot of concepts here. We have the word that gets around a lot is disruption in our terms. That is fundamentally new concepts and engineering practices with large impact. But we have a more fundamental question, which is the organization of a company, or generally, to put it in other words, what algorithm do we use so all the nodes in the network make the decisions that ultimately lead to success. The nodes in wealth generation or in investing are people. The company is the organism or the network. And how can we organize a company so the nodes, i.e. the people, make the right decisions, and we have this beautiful character of the network which is very important, and that is that we surface explanatory knowledge, or in plain English, we surface creativity, we surface problem solving ability, we surface solutions to problems at the right level in the organization. In other words, how do we make sure that we make the right decision at the right level without always going to the top, having a top-down organization, having sort of command and control? How do we decentralize? We discussed Netflix and Reed Hastings, and his approach is fundamentally to set a base, a cultural base. So he's less mission-driven, he's setting a cultural base, and the cultural base is things like candor, transparency, honesty, talent density. So even beyond culture, he's setting just simply the base of talent. You know, it's a bit like if you have a soccer team with 11 just top players, your chances of winning are much higher than if they're not top players, and regardless of any kind of culture. So this is kind of the idea. Now let's jump into Tesla. We discussed Tesla, and towards the end of the first episode of today, we spoke about iteration. So we have a combination. We have a leaderless consensus within Tesla. This is all conjecture, by the way, so we assume that's the case. We don't know, and the reason we're putting out this episode today is because it's highly likely that maybe within a year or so we will have a book written about Tesla and SpaceX, so we can then test our thesis against the reality, because I hope that Elon Musk will talk about this in the book. So the idea, how is Tesla organized, or how does Elon Musk run his companies? And the idea is that we have a sort of Reed Hastings-esque leaderless consensus here. So we have all the aspects: culture, candor, transparency, openness, talent density. But we have one more thing, and that's very important with hardware-driven companies, or with companies like Tesla that are driving engineering to the next level, and that is iteration. So how do we introduce iteration into an algorithm to run as a company? Or when I say algorithm, it just means if people are the nodes, the network is the company, what's the algorithm running this company? And the algorithm is all of the Reed Hastings stuff plus iteration. Iteration is, in our view, the fundamental base of disruption. So if you have fundamentally new concepts and engineering practices with large impact, the only way you can actually push them forward and make tangible changes or succeed or create something valuable is through iteration. Because how do you know that the fundamentally new concepts are actually good concepts? How do you know that the new engineering practices are good? And how do you know which ones are good and which ones are bad? Fundamentally new concepts and engineering practices by definition mean that something is new and you don't really know what the right application is. So what you need to do is you need to find out. You need to find out which architecture, for example, in the battery technology is the right one. Tesla chose lithium iron phosphate. And it's a battery that was around. CATL, the Chinese manufacturer, is selling cells like that to companies like BYD. But to cut a long story short, these batteries are way subpar, the cars are subpar, there's absolutely no penetration beyond some low-level Chinese customers that probably are subsidized. So how can we make lithium iron phosphate marketable at a high level, at a Tesla level standard and branding? And there are probably ways. I'm sure that decision was made in a sense, look, there are theoretical ways to do it, there are practical ways to do it, but we don't know exactly what. So what Tesla is doing now is making the Model 3 in China, MIC, and making LFP batteries and shipping them to Europe and testing. And they are literally testing at the cost of losing the customer in Germany in particular. There's been some reports about that, and the problem is the batteries have certain advantages, they have certain disadvantages. The disadvantages are things like charging times are longer than we thought, and the range in certain colder temperatures are not as good as we thought. So this is iteration. So, Tesla has already improved some of it with software. They will continue improving. They will continue improving the existing cars with software, and they will continue making amendments to the chemistry, the architecture, the battery management software, the powertrain, the interaction between all these things. So it is probably feasible to think that within the next 6 to 12 months, the LFP battery will be at least at the standard of a 35,000 euro car, which is exactly what they're selling right now at the MIC Model 3 in Germany now, or excuse me, in Europe. So this is, when I said the cost of iteration are fundamentally the drivers of disruption. So the higher the cost of iteration, the less disruption we will get, and vice versa. The lower the cost of iteration, the higher the disruptive forces are. And here's the thing, like, you have to build a company. So you're Elon Musk, you're in 2002, you're starting Tesla. My guess is he's not thinking too much about these things. It's just, this happens to be his nature. This is how he operates. He goes, listen, we need to create an electric car company that succeeds. We need to build technology that succeeds. We need to solve problems. And this is the innovation stack. This is exactly what the innovation stack is. The innovation stack is basically a sequence of iterative processes that continuously build on each other and compound. So what you have to do when you build an innovation stack is you have to make sure you stay within the realm of compound. This is the key. You don't want to just innovate for the sake of innovation. You don't want to solve problems that have no compound power. You want to keep building, solving problems, generating new problems, solving those in a way that you can compound, at least within a certain feasible time frame. Of course, I think, again, at Tesla, maybe solving LFP will eventually, in 5 years, be irrelevant because the 4680 will solve a lot of the problems. But right now, within the next couple of years, there should be some compound effect, which means the car should get better, the car should get lower cost, the competition should be put more on the back burner. You should run away faster from the competition, sell more cars, make more money, invest more in R&D, make the 4680 faster, etc., etc. So all these things are kind of in the next, when I say compound, it doesn't always have to compound forever. I think that's just an impossible task. But there should be some compound value in the iterative factor that you're using. So, and the difference here is, I think this is very important. And I've learned this in many ways. I've learned this, let's say, reading Oliver Stone's biography. I've learned this listening to Sean Carroll, who talks about his biography as a scientist. The difference between Sean Carroll and almost every other scientist that I know, not everybody, but pretty much 99% of scientists, is Sean Carroll is an iterative guy. He tries new things. He tries and fails. He tries and fails. He actually was even rejected by the establishment. He didn't get tenure at the University of Chicago, where he was an assistant professor. And I think to some extent it's because he was different. But anyway, fundamentally what he's built is an innovation stack of science, of effectiveness as a scientist, as a teacher, and as a popular media person, because he is kind of like if you want, a very popular media person talking about scientific subjects. So Sean Carroll has built an innovation stack around iteration, and I'm using Sean Carroll's example here just because it just shows that the concept of the innovation stack, the concept of iteration and all these things, they're not just limited to Tesla or Square or whatever. This is a life lesson. Find a way to iterate at low cost and keep iterating. Here's another example. I have started bodyboarding about a year ago. I am now pretty good, and I would say pretty up there when it comes to the average bodyboarder here in San Francisco. I'm doing Ocean Beach on normal days, but I cannot do Ocean Beach on high swell days. I can obviously not go to Mavericks, none of that stuff. The reason I'm bringing up this example is because I don't think this is a question of iteration. There is also the necessity for me as a bodyboarder to go, let's say, from 8-foot waves on Ocean Beach to 15-foot. So to make that transition from 8 to 15, and maybe the threshold somewhere there is 10, 11, I haven't tested it yet. But at some point, I need a fundamentally new concept and practice, because it's not just an iteration. Because otherwise, what happens is you just get, killed by not killed, but you're going to get crashed by the waves. You can't catch them with the fins just alone. The board doesn't float enough, etc. So you need new ideas. The same problem surfers had probably 20 years ago, when people like Laird Hamilton revolutionized tow-in surfing. So they said they couldn't paddle in, and they had to figure out another way to paddle into higher waves, and then they could catch them. The problem often with waves is not actually the wave itself is surfable in many circumstances, but it's getting out to the wave and then catching the wave, because the speed could be detrimental, etc. So I mentioned this just to show that sometimes in life, in situations, you can't just get from A to B through iteration. And this applies to Tesla as much as it applies to bodyboarding. Tesla and SpaceX are companies that are built on iteration, but it also requires explanatory power, it requires creativity, it requires all the things that traditional science and engineering have, which is the guy that sits down and thinks really hard about the problem and writes down equations. And then we have the iterative aspect, which is, okay, let's try this, let's tweak it, let's try this, let's tweak it, building the innovation stack. So it's a little bit of both. And again, we don't know what the exact formula is within Tesla. We are very curious to read the book. The reason these 2 episodes today were published is in particular because we would like to calibrate ourselves when the book comes out and see if we were right with our conjecture that Tesla is actually a company that is built on leaderless consensus, a la Reed Hastings. So there is all the ingredients that are necessary for that. On top of that, it is built on iteration. And the question how iteration is exactly formally built into the organization, that I don't know. We don't know. We haven't been able to get to the bottom of that question, even when talking to the company. It is again a conjecture that it happens through sort of tacit suasion, if you want. So it's just expected from people at almost any level of the company to make decisions that are appropriate to their level of development, to their level of positioning, to their level of intellectual power, to their level of status and whatever else matters within a company. So that is our conjecture. Again, we don't have hard data, and we will only have once the book comes out. Musk doesn't talk much about the decision making within the company, but given the speed, given the amount of innovation, given also the behavior of the company, like for example, they're willing to sacrifice the German customer with LFP MIC cars just to iterate and learn. And That could in some ways be considered as too high of a cost of iteration. Maybe it is, maybe not. We shall see. The good thing about Tesla right now is that even if they bring a car which is maybe a little bit subpar relative to their own standards, the competition still doesn't match up, so they can iterate very fast. And this is another very important thing. The cost of iteration for a company depend very often also on the cost of the iteration for the others, or the willingness of iteration for the others. And this brings me to the last point, and this is the fundamental question within Reed Hastings' book, where Reed talks about this whole idea of having empower people to make their own decisions. And he always looks at it from one perspective, which is, what if somebody makes decisions that I don't like as a boss? And that's fine, he has answers for that. But what if somebody doesn't make decisions? What if my underlings, or the people that work for me, what if they don't take enough risk? The same problem was famously encountered within Amazon. And I think this question can be answered the same way. If you want people to take risk within your company, if you want people to actually take initiatives, start solving problems, put responsibility and accountability into their own hands, you need to lower the cost of iteration. That means also, for example, lower the cost of failure. Don't punish them. But again, this is also to some extent a function of the competition. If your competition has very good products, so for example, if you're in a commoditized market where I don't know, the traditional car market, BMW has a certain type of car, and Mercedes has one, and Audi. It's very, very costly to iterate, because if you're wrong, you lose market share right away. You can show it. Economics 101. If you're Tesla, your cost of iteration are lower, and they actually keep falling down. And this, I would say, this is almost like Moore's law, because you're running away from competition, you're creating a new market, you're developing new products and winning market share. Your cost of iterations are lower, because if you make a mistake, people will still trust you, people will still buy your car, because the competition is way, way behind you. So this is almost another kind of law of compound, or like I said, Moore's law, where you have this ability to lower the cost of iteration almost non-linearly, or faster, much faster, by iterating faster. It's a circular reference here, but it's an important circular reference, because this is what compound interest does. This is just another way to look at compound interest. If you manage to run away from the competition, then a couple of years down the road, once you run away from the competition and you own the market, your cost of iterations are even lower, because now you own the market, and people will not switch that fast. What you don't want is, you don't want the market to get commoditized. And this is the fundamental thesis of our Tesla investment, which is Tesla does not want companies to catch up, because then the cost of iteration will go up if commoditization happens in the market, and that will be very, very bad for the development of the whole market. And therefore Tesla needs to keep going at the pace that they're going, even accelerate if they can, to keep competition at bay, so they can keep innovating, winning market share, lowering their cost of iteration, which allows them to innovate faster, win more market share, and thus keep the innovation stack growing even faster. Thank you.